Welcome to the Explainer. Let's jump right into the hidden physics of how our drinking water actually gets purified.
Ever wonder how we strip out invisible dirt from water when it literally just refuses to sink?
The main culprit here? Colloids. These negatively charged particles repel each other, so they'll never settle naturally.
To fix this, engineers use a really clever three-step chemical and mechanical process to clean things up.
First, coagulants neutralize those charges. Then, gentle mixing triggers a snowball effect, clumping them into large, visible flocs. Particles collide randomly at first, but stirring shifts water speeds, forcing smaller pieces to crash into heavier clumps.
Once these visible macroflocs form, we hit a fascinating crossroads. Do we push this waste down or up?
Let's look at traditional sedimentation first. It relies entirely on gravity to pull those dense, heavy flocs straight down.
Heavy flocs sink past lighter ones, but their downward speed absolutely must beat the clarifier's upward water flow.
But what if the water is full of algae, or those flocs are just too fragile to sink?
Enter dissolved air flotation, or DAF. It totally flips the script, using upward buoyancy instead of downward gravity.
In DAF systems, we inject microscopic, pressurized air bubbles measuring just 10 to 100 micrometers across.
These bubbles get physically trapped inside the porous flocs. They act like tiny life jackets carrying them upward.
Clean water gets pulled from the bottom, while that floating layer of sludge is mechanically scraped off the top.
Here's the comparison. Sedimentation uses gravity to drag heavy waste down, while DAF harnesses buoyancy to float it up.
So, which is better? Honestly, neither is universally superior. It entirely depends on your raw water's specific chemistry.
Next time you drink tap water, ask yourself, was this purified by heavy sinking or rapid floating?